Hello friends, this is Rohit from careerdost.in. Welcome to our YouTube channel Career Dost. The topic that we are going to deal with today is permutations. So before starting this video, let's first show you what will be the content of this video. So as you can see, we have divided the content of this video in two sections. In the first section, we will be discussing about definition, basics and formulas of permutations, then factorial table to memorize, and then in the second section, we will discuss types of permutation problems. So as you can see, there are two types of permutation problems. One is numbers problem and the other is words problem. In numbers problem, we have two types, zero type problems and non-zero type problems. In the words problem, we have six types of problems, which are: the first is repeated letters and non-repeated letters. Second is repetition allowed and repetition not allowed. Third is always together. Fourth is never together. Fifth is odd and even places. Sixth is no two together. So we will discuss each of them with examples. So before going into depth, first let us understand what do we mean by permutation. So permutation means the number of ways in which a group of things can be arranged. In terms of mathematics, we can say it's an arrangement of its members into a sequence or linear order, or if the set is already ordered, a rearrangement of its elements. Let's see the formula. Formula is NPR. We denote permutation like this: n factorial divided by n minus r factorial. So this is the formula. So NPR is the permutation, as I told you, and n is the total number of objects and r denotes the number of objects selected. So let's take an example to understand it further. So this is a simple example of permutation for you to understand. So let's say the letters are ABC. So now in how many ways these letters can be arranged? So the first way is ABC itself. Second is we can arrange it like ACB, BAC, BCA, CAB and CBA. So there are in all total 6 ways. So it's very easy to arrange 2-letter words or 3-letter words, even 4-letter words you can arrange. But now let's see, if you have 10 letters word, then it will be very difficult to arrange them in this way. That's when we use the formula of permutation. So let's take an example of 5 letters. So this is A, B, C, D, E. So they are asking us to arrange these 5 letters in 4 spaces. So number of letters that we have is 5 and number of spaces that we have is 4. So we have to arrange these 5 letters in 4 spaces. So what is the formula of permutation? So here n will be the total number of letters. So 5 will come here. N is equal to 5. And we have to arrange it in 4 spaces. So r will be equal to 4. So we will write it as 5p4. So which will be equal to 5 factorial divided by 5 minus 4 factorial. So now just simplify it. You will get the answer for it, which will be 5 factorial by 1 factorial, or simply 5 factorial you can say. Now let's consider another example. Let's say we have a 9 letters example, which is A, B, C, D, E, F, G, H, I. And now we have to arrange this in 1, 2, 3, 4, 5, 6 spaces. So the formula of permutation is NPR is equal to n factorial divided by n minus r factorial. So n here is 9 and r here is 6. So it will become 9 factorial divided by 9 minus 6 factorial, which will give us 9 factorial divided by 3 factorial. You just simplify it and you will get the answer for it. Now the very important thing for you to crack permutation problems easily is that you remember all the factorials from 1 to 7, at least from 1 to 7. The factorial of 1 is 1, factorial of 2 is 2, factorial of 3 is 6, factorial of 4 is 24, factorial of 5 is 120, factorial of 6 is 720, factorial of 7 is 5040. And it will be good if you know the factorial of 8 and 9 as well. So we have just put in case of reference. So why do we need to remember this is because in most of the permutation problems you will find the combination of these factorials predominantly. So if you know these numbers thoroughly, you don't have to multiply it every time, like 7 into 6 into 5 into 4 into 3 into 2 into 1 for 7 factorial, or for 6 factorial you don't have to multiply it every time, or for 5 factorial. If you simply know it, the factorial of 5 is 120, factorial of 6 is 720 and factorial of 7 is 5040. Now let's dive deep into permutation and see the two types of various problems that you might face in the permutation exam. So there are two types of permutation problem. So one is when we deal with numbers we have zero type problems and non-zero type problems. Second is when we deal with words. When we deal with words, we have 6 types of problems. So one is repeated letters and non-repeated letters. Second is repetition allowed and repetition not allowed. Third is always together. Fourth is never together. Fifth is odd and even places. Sixth is no two together. So these are the main types of problems that can come from permutation. So once you are through with all of these types of problems, it will be very easy for you to solve permutation problems. So in this section we will be dealing with the topic permutation numbers. So as I have told you earlier that there are two types of concepts that you will see in the permutation when dealing with numbers. So first we will discuss non-zero type. So let's solve a question. So the question is, in how many ways a 3-digit number can be formed using 1, 2, 3, 4? So they have given us 4 numbers and are asking us to form 3-digit number. So we know the formula is NPR is equal to n factorial divided by n minus r factorial. So 4 digits they have given, n will be 4 here, and are asking us to form a 3-digit number. So r will be 3 here. That's the reason 4p3. So it will give us 4 factorial divided by 4 minus 3 factorial. So which is nothing but 4 factorial. So 4 factorial, if you already know from that table, if you remember, so 4 factorial is nothing but it will give us 24 ways. So that means there are 24 ways in which 1, 2, 3, 4 can be arranged to form a 3-digit number. So let's move to another example. So the question is, in how many ways a 4-digit numbers can be formed using 1, 3, 4, 5, 7, 9 when repetition of digits is not allowed? So you see here, important thing to notice is when the repetition of digits is not allowed. So they have given us 6 numbers and asking us to form 4-digit number with no repetition. So this will be 6p4, which will be equal to 6 factorial divided by 6 minus 4 factorial. So this will give us, upon solving, 6 factorial divided by 2 factorial, which is nothing but 6 factorial means 720 by 2, which will give us 360. So this means that there are 360 ways in which a 4-digit number can be formed using 1, 3, 4, 5, 7 and 9. So in next type of problem we will see what happens if we have repeated number. So this is example 3. So the question is, in how many ways a 3-digit number can be formed using 4, 5, 6, 6, 7, 8. So here you can see 6 is repeated twice. So they are asking us to form a 3-digit number out of the given 6-digit number. So as usual we will write it as 6p3. We know the formula. So we will write it as 6p3. The catch here is 6 is repeated twice. So what we will do is divided by the number of times the number has been repeated. That is 2 times. So in this case 6 is repeated twice. So what we did is we have to divide the permutation by the number of times the digit has been repeated. So in this case it was repeated twice, so we have divided by 2 factorial. So when we are going to solve it, it will be like 6 factorial divided by 6 minus 3 factorial whole divided by 2 factorial. So this will give us, so once you solve this you will know the way in which a 3-digit number can be formed using the given numbers. Now let's move to second type of problem, that is zero type. So let's solve an example. So the question is, in how many ways a 4-digit number can be formed using 0, 2, 4, 6? Remember this is zero type, so 0 is included. So what we will do here is, let's first consider 6. So if we have 6 in the first place, what are the other ways in which other numbers can be used here? So this means that there are 3 factorial ways for the digit 6. Similarly for digit 4. The digit 4 will have the same thing, that is 3 factorial ways it can be arranged. Now let's consider 2. So 2 will also have the same thing. It will also be arranged in 3 factorial ways. Now let's consider forming a number using 0. So it's just a common sense. It will never make sense because if you put 0 in the first place, it will automatically become 3-digit. It will never be 4-digit. So this possibility is not possible. So we can say that number of ways a 4-digit number can be formed using 0, 2, 4, 6 is 3 factorial plus 3 factorial plus 3 factorial. So that is 3 factorial means 6. So 6 plus 6 plus 6 is equal to 18 ways. Okay, let's understand it better. We will take another example. So this question is, in how many ways a 3-digit number can be formed using digits 5, 6 and 0? This is example 2. So let's consider 5. So if we have 5 in the first place, what are the other ways in which other numbers can be used here? So it will be 2 factorial. Similarly for 6, it will be 2 factorial again. But when placing 0, it will never make sense because of the same reason as we discussed earlier. Because if we put 0 here in the first place, it will not form a 3-digit number. It will automatically form a 2-digit number. So this is nullified. So in 4 ways we can arrange 5, 6 and 0 to be a 3-digit number. So let's move to type 2, that is words. The most important types in permutation problems. So in this section we will deal with the topic permutation problems with word type, and problem is first type, that is repeated letters and non-repeated letters. So let's first see with non-repeated letters. So the question here is, in how many ways a word can be arranged? So we have some examples like dog, coin, phone and Sunday. So when you are asked this type of problems, especially for non-repeated letters, there is a very good shortcut, that is count the number of letters. The number of letters factorial will be the answer to this problem. So for example, for dog we have 3 letters, so it will be 3 factorial. In coin it will be 4, so 4 factorial. For phone it will be 5 factorial, and for Sunday it will be 6 factorial. Just remember that whenever we have non-repeated letters, just count the number of letters in the word and place the factorial accordingly. Now let's move to repeated letters. So in how many words a word can be arranged? First letter is glass, second is September, third is aptitude, fourth is Philippines. So how to solve this? First count the number of letters as we were doing in non-repeated letters as well. Then number of letters factorial, then divided by the number of repeated letters factorial. What does this mean? For example, in glass this S is repeated twice, so we will be putting 2 factorial in the denominator. 5 factorial divided by 2 factorial. So the number of letters in the word is 5, so we put 5 factorial divided by the number of repeated letters. So for example, S is repeated twice, so we put it 2 factorial. Similarly for September, it will be 9 factorial, 9 letters in the word September, so 9 factorial divided by 3 factorial because E is repeated thrice. Once you solve it, you will get the answer. Similarly for aptitude, it will be 8 factorial divided by 2 because T is repeated twice, so 2 is put in the denominator. In the case of Philippines, we have total of 11 letters. 11 divided by 3 factorials for P into 3 factorials for I. I is also repeated thrice, so 3 factorial into 3 factorial. So for Philippines, it will be 11 factorial divided by 3 factorial into 3 factorial. I hope this is easily understandable to you. So with this, we come to the end of the part 1 of permutation problems video. We will continue the remaining permutation types in our second part of this permutation problem series. Let's just recap what we discussed in this video. So we have started this video with the basic concept of permutation, definition, formulas, examples of permutation. Then we discussed about the factorial table from 1 to 7 that you need to memorize. After that, we discussed types of permutation problems. First type was numbers, in which we discussed non-zero types and zero types permutation problems with the help of examples. After that, we discussed second type, which was words, in which we discussed repeated letters and non-repeated letters. So we hope that you understood the concepts. We will discuss the remaining permutation types in our next video. So hope you like the video. If you do, please don't forget to like and share the video and subscribe to our YouTube channel. We will be making similar videos in aptitude category. Thank you.